So let's just get started with completing this pattern here at the top. So what do you think the answer is to this? What is x plus y to the power of 0 equal? 1, because anything to the power of 0 is 1. Okay. What about x plus y to the power of 1? Anything to the power of 1 is just itself. So x plus y to the power of 1 is just x plus y. All right, so for the other ones, I want you to go ahead and make a box. Go ahead and make a box, multiply x plus y times x plus y. See what you get. Is that what you got? Did you get x squared plus 2xy plus y squared? Okay, let's make another box. So now what I want you to do is take this answer and multiply that again by x plus y. We're only going to the power of 4. So go ahead and fill in the squares to figure out x to the power of 3. Because we're going to talk about the pattern. There is a pattern to binomial expansion. So you should have 6 squares. So we'll start off with x to the power of 3. And then you have to have the same exponent. So notice that these two both have x squared y. So that would be 3x squared y. And the same thing here. This has a xy squared. So again, that would be 3xy squared plus y cubed. All right, last one. Let's make another box. Go to the power of 4. So our box is going to be just a little bit longer. And we're going to have a 4 by 2, so we're going to need 8 squares. So across the top, you have your x to the power of 3. All right, go ahead and fill in your 8 squares. Okay, so when we pull that together, we get x to the 4th. I'll write this one in blue. So x to the 4th. And then these are like terms. So when you add that together, you get 4 x cubed y. And then these two are like terms, and that would be 6 x squared y squared plus 4 xy cubed plus y to the 4th. Okay, so we just expanded that same binomial, and let's look at it to see what we notice, because there is a pattern to this. So the first thing is, what do you notice about the number of terms? So we started off, look at the number of terms. What's happening every time we expand? So here we only have 1 term. Then we have how many terms? 2. And then what about here? 3, 4, 5. So what's happening every time we add an exponent to the number of terms? All right, it increases by how many? 1. So go ahead and write that down. So every time we add an exponent, the number of terms increase by 1. So that's really important. That's part of the pattern. Okay, what do you notice about the exponents on x? So when we look here, we have x to the 1st, and then we have no x's. Then here we have how many x's? 2. How many what's the exponent on this one? 1. And then there aren't any x's, so that means the exponent is 0. So the exponent on x is going 2, 1, 0. Here it goes 3, 2, 1, none. 4, 3, 2, 1, none. So what do you notice about the exponents on x? They're going what? They're going down. So write that. And the opposite is happening to the exponents on the y values. So my exponents on x are going down, but the exponents on y are going up. That's part of the pattern. Let's look at 3. What about the sum of the exponents? So here we have 2 and an invisible 0. And then we have 1 plus 1, which is still 2. And then here we have a 2. So when the exponent is 2, the sum of my exponents are equal to 2. Here in this row, when we had an exponent of 3, we started off with a power of 3. And then, let's see, maybe it'll be helpful if I write it in. So we have a 1 and a 1. So we have 2 plus 1, which is still 3. 1 plus 2, which is still 3. 3. See it? So the exponents are adding to the power. Same thing when we get to the 4. So we have 4, and then we have 3 and 1, and then we have 2 and 2, and then we have 1 and 3, and then we have 4. So the sum of the exponents are equal to the power. That's what you should notice about that. Now the furthest we're going to expand, I believe, is 5, and it's going to be the same thing. But we're not going to make boxes to expand. We're going to use the pattern. There is a pattern. Okay, the coefficients, this one might be a little bit harder to recognize, so we're going to actually fill out our triangle to see those coefficients. So let's go to the back page and start filling out our Pascal's triangle. So Pascal's triangle, this first row, this represents row 0, which is this means that you have an exponent of 0. So everything to the power of 0 is equal to what? So we start off our triangle with a 1. Our second row, row 1, our numbers are 1 and 1, because we had the x and the y, and the coefficients of x and y were just 1. Okay, so now moving forward, we start with 1 and we end with 1, and the number in between is the sum. So what do you get when you add these together? 1 and 1 gives you what? 2. So go ahead and look at your x plus y squared. When you look at x plus y squared on the other side, go to the other side. Do you notice that your coefficients were 1, 2, 1? Okay, so that is for anything squared, your coefficients are 1, 2, 1. So the next row, we start with the 1, we end with the 1. So now you're adding these together. So 1 plus 2 would give you a 3 here, and 2 plus 1 gives you a 3. So that's row 3. Row 4, you start with the 1 and end with the 1. What do you think the next number is going to be? Because you're adding 1 and 3 together, which is going to give you 4. And then you're adding the 3 plus 3, which gives you 6. And then 3 plus 1, 4. That's as far as we got. So let's see if you can fill in the next row by yourself. See if you can figure out what the next row would be in the triangle. So we start with the 1, end with the 1. So you're adding 1 plus 4, which gives you 5. And it's symmetrical, so I usually fill in 2 squares at once. So I know that this is going to be a 5 and this is going to be a 5. And then here, to get the middle numbers, I'm adding 4 plus 6 and 6 plus 4, which gives you 10. Who had that for that row? All right, keep going. Fill in the next row. You got to go all the way to the bottom. We got a long way to go. So on Friday, you have your homework due and you have a skills check over binomial expansion. You will have to recreate the Pascal's triangle, but this is going down pretty far. So I don't know how many rows we'll have you do, but it's a pattern. Who got that for their row 6? 1, 6, 15, 20, 15, 6, 1. Okay, let's do the next row. Let's keep going. So when I did this yesterday, I messed up one number. And because if you mess up one number, everything below it is wrong. So I was so mad at myself. So make sure you agree with each row before you go to the next row. Okay, did you get that for that row? All right, one more row to go. Now, there is no end to the Pascal's triangle. It keeps going forever and ever and ever, but we made it to row 11, so that's pretty good. So now we're going to use this to expand a binomial. So instead of making boxes to expand, we're going to do it using the pattern, which is actually a lot easier. So let's go ahead and do x plus y to the power of 7. So on the next page. So without Pascal's triangle, we would just have to continue what we did on the last one. We have to figure out x to the 5th and then multiply that by x to xy and then take that answer times xy. But we're not going to do that. We're going to look at Pascal's triangle. So if the exponent is 7, these are my coefficients right here that I'm going to use. So let's go ahead and rewrite those on our next example. So the coefficients, first of all, we're going to have how many terms? We're going to have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 8 terms, and these are the coefficients of the terms that we're going to use. Okay, so we're going to start with, you always start with the first number to the power of 7. The second term is to the power of 0. So I'm starting x to the 7th, y to the 0. So we have x to the 7th, 1x to the 7th. I got to write small because, and then you don't have to write the y to the 0. Plus, what's the next number in that row? In row 7, what's the next number? 7. And now my x's, remember, the x's go down, the y's are going to go up. So that would be x to the 6. And now my y is up to 1. Plus, what's the next number in the row? 21. X's go down, y's go up. Next number. 35. X's go down, y's go up. And these should always add to 7. Every term, the power should add to 7. So we have 6 plus 1, 5 plus 2, 4 plus 3, plus we have another 35. X goes down, y is going up, plus 21. X goes down, y goes up, plus 7. X goes down, y goes up, and then we made it to the end. So x is down to 0, so you don't have to write that, and y is up to 7. So you see how much faster that would be than what we were doing in the beginning, making boxes. And it's all because of the Pascal's triangle pattern. Yes, Gabby?
Are we going to have to know that by heart or?
Well, it's a pattern. So if you should know how to create it. 1, then 1, 1, and then you're just making the pattern. So yes, you should understand the pattern.
Yes, I mean that. I know that, but I mean, if we were to use that on the test, would we be able to use that, or would you see if no?
You'll have to make one. Yeah. But again, you won't have to go all the way down to row 11. I think it just goes up to 5. And it's not a test, it's just a skills check on Friday. All right, so let's go ahead and look at part B. So part B, we only have to go to row 3. So I'm looking at this row. And so it's only going to be 4 terms because it's to the power of 3. So because of this negative, though, we have to treat it a little differently. Okay, so what we're going to do is write it out. We're going to start off with 1. And then I have x to the 3rd. And then negative y to the power of 0. So we don't have to worry about that because it's just going to equal 1. And then my next term is a 3. So what I want you to do, though, is put the x, I'm going to put that in parentheses. Because if it's more than one thing, when they get harder, it's just easier to put them in parentheses. And then that negative y, because it's negative, I'm going to put it in parentheses. Because that negative could change the sign of that 3. We have to look at it. So then my next term, plus 3, x goes down. My second term, which is negative y, goes up. Lastly, plus 1. So x is down to nothing, so we don't have to write that. Y is up to a 3. So we just need to simplify this. Excuse me. So when I simplify this here, that just becomes 1x squared, 1x cubed, sorry. So what do you think is going to happen here? I shouldn't put a plus sign because we don't know if it's plus. Because I have 3x squared, but then I have that being multiplied by negative 1 to the first. Well, negative 1 to the power of 1 is negative. So I really have 3 times 1 times negative 1, which is going to make that positive 3 a negative 3. Anytime a negative is raised to an odd power, it stays negative. For this term, though, I have negative 1 squared. Negative 1 squared is positive. So that's going to be 3 times 1 times positive 1, which is just a positive 3. And then negative y, or negative 1 to the power of 3. What do you think negative 1 to the power of 3 is? Is that positive 1 or negative 1? Negative. So I have a 1 times a negative, which is going to make that final term negative y cubed. That's it. That is Pascal's triangle. We'll do one more, and then we'll practice this tomorrow. And it's pretty simple, though. So I think it'll be an easy little skills check. So we're in row 4. So going back to Pascal's triangle, row 4, that would be this one. So these are my coefficients that I'm going to have. I'm going to use the numbers 1, 4, 6, 4, 1. So I'm going to start off with the 1. And then x is to the power of 4. Plus, the next term is 4. X to the power of 3. But now my second term is a number. So I'm going to put that in parentheses. So that negative 3 is to the power of 1. Plus, the next number is a 6. And we have our x squared. We always put our negatives in parentheses. So negative 3 squared plus 4 x to the first negative 3 to the power of 3 plus 1. So now my x's are gone, and my next number is negative 3 to the power of 4. You always want to make sure before you start multiplying that your exponents are adding to 4. So I have a 4, then I have 3 plus 1, which is 4, 2 plus 2, which is 4, 1 plus 3 is 4, and 4. So now we need to simplify it. So my first term is just 1x to the 4th, and you can always just put x to the 4th. So now you need to figure out what is 4 times negative 3 to the power of 1. So what is 4 times negative 3 to the power of 1? So we have a negative 12 x cubed. For the next one, we have 6 times negative 3 squared. So negative 3 squared is 9, positive 9, and 9 times 6 is 54. So we have negative 54x squared. And now we have 4 times negative 3 cubed. So go ahead and type that in your calculator. Take negative 3 and make sure you're putting it in parentheses whenever you have an exponent. So negative 3 to the power of 3 times 4. You should get negative 108. Did you get negative 108? Negative 108x. And then for our last one, you have negative 3 to the power of 4. Negative 3 to the power of 4 would be, first we know it's positive, and I think that's 81. Okay, I want to give you a minute to start working on homework 13. Tomorrow we're going to do a little bit more practice. It's pretty easy, nothing difficult about it. So we're doing a little brain break after all that trig we had to do.